The desert environment is characterized by extreme temperatures. Scarce rainfall is a defining feature of desert ecosystems. Deserts receive intense sunlight throughout the year. Desert flora and fauna have adapted to survive with minimal water. The lack of cloud cover contributes to high daytime temperatures and rapid nighttime cooling. Desert landscapes are often characterized by sandy terrain, rocky outcrops, and sparse vegetation. Deserts experience water scarcity due to low rainfall and high evaporation rates. Limited water availability creates a challenging environment for plant survival in deserts. Plants in deserts have adapted unique water conservation strategies to survive. Deep root systems allow desert plants to access groundwater sources far below the surface. Conserving water is crucial for the survival and sustainability of desert ecosystems. Cacti possess a thick, waxy cuticle to minimize water loss. The cuticle acts as a barrier, reducing transpiration in arid environments. Reduced transpiration is crucial for survival in water-scarce conditions. The waxy composition of the cuticle provides a hydrophobic barrier. This adaptation enables cacti to thrive in harsh, dry climates. The waxy cuticle acts as a barrier on the plant's surface. This barrier prevents water from evaporating from the plant. The cuticle's hydrophobic properties contribute to its effectiveness as a water barrier. The thickness and composition of the cuticle vary depending on the plant species and environmental conditions. By minimizing water loss, the waxy cuticle helps plants survive in dry environments. Cactus spines reduce airflow around the plant, minimizing water loss in arid environments. The spines act as a protective barrier against herbivores, preventing them from consuming the plant. Spines create a microclimate around the cactus, reducing direct sunlight exposure and lowering surface temperature. The density and arrangement of spines directly influence the amount of water retained by the cactus. Spines minimize transpiration, a process where water evaporates from the plant's surface. The protective and water-conserving functions of spines are essential for cactus survival in harsh desert conditions. Cactus spines create a microclimate around the plant surface. This microclimate reduces the temperature directly adjacent to the cactus. Spines reduce water evaporation from the cactus surface. The reduction in temperature and evaporation helps the cactus conserve water. Spines effectively lower the plant's water requirements in arid environments. Succulents are characterized by their ability to store water efficiently. Water storage occurs in specialized tissues within leaves, stems, and roots. Thick, fleshy leaves are a common adaptation for water storage in succulents. Some succulents store water in their stems, which become swollen and bulbous. Succulent roots are often fibrous and shallow, allowing rapid water absorption from rainfall. This water storage capability enables succulents to thrive in arid environments. Succulents have specialized cells that enable them to store large amounts of water. The internal structure of a succulent is optimized for water retention in arid environments. Water storage cells, known as hydrenchima, contain large vacuoles to maximize water capacity. The thick, fleshy leaves of succulents reduce water loss through transpiration. Succulent anatomy allows survival in environments with limited water availability. Desert plant roots adapt to arid conditions by maximizing water absorption. Time-lapse visualization illustrates root growth patterns in response to water availability. Deep root systems access groundwater sources far below the surface. Shallow, spreading roots efficiently capture surface water from infrequent rainfall. Root architecture is a crucial adaptation for survival in water-scarce environments. The efficiency of water absorption directly impacts plant health and survival rates. Different root systems have evolved to efficiently capture water from infrequent rainfall. Shallow, widespread root systems maximize water absorption from brief surface rainfall. Deep taproot systems access water stored deep underground, surviving prolonged droughts. Root hairs significantly increase the surface area for water absorption in both root systems. The distribution and density of roots are directly related to rainfall patterns and soil composition. Desert plants often have small leaves or no leaves to reduce the surface area exposed to the sunday. Reduced surface area minimizes water loss through transpiration in arid environments. The absence of leaves is an adaptation strategy for conserving water in desert plants. This adaptation allows desert plants to survive in harsh, water-scarce conditions. Leaf size is inversely related to water loss. Smaller leaves generally conserve water more effectively. Smaller leaves have a higher surface area to volume ratio, reducing transpiration rates. Plants in arid environments often exhibit smaller leaf sizes as an adaptation to minimize water loss. The rate of transpiration is influenced by leaf size, with smaller leaves exhibiting lower transpiration rates. Specialized hairs or scales on plant leaves reflect sunlight. Reflection of sunlight reduces leaf temperature, preventing overheating. These adaptations are crucial for plant survival in harsh desert environments. The reflective structures act as a natural sunscreen, protecting the plant. Reflective surfaces on plants help maintain a cooler temperature. Reflection of sunlight reduces the amount of heat absorbed by the plant. Reduced heat absorption minimizes the rate of transpiration. Transpiration is the process by which plants lose water vapor through their leaves. By reducing transpiration, reflective surfaces help plants conserve water. Some desert plants survive by entering a dormant state during dry periods. Dormancy allows these plants to conserve resources and withstand harsh conditions. When rain arrives, dormant plants rapidly grow and reproduce. Rapid growth ensures quick reproduction before the desert dries out again. This adaptation allows plants to thrive in environments with unpredictable rainfall. The life cycle of these plants is synchronized with the availability of water. Desert plants exhibit remarkable adaptations to survive in arid environments. Deep root systems allow desert plants to access water far below the surface. Reduced leaf surface area minimizes water loss through transpiration. Waxy coatings on stems and leaves prevent excessive evaporation.